We're team number 2, and we're going to present joining processes in liquid state, also known as fusion. Our teammates are Alejandra Padilla, Daniela Banda, y Bernardo García. First, we're going to do projection welding, also abbreviated as PW. A little description of this process is that this projection welding is a resistance weld where the design or the shape of the part is used to make more discrete individual point contacts to concentrate the current during the welding process. In most applications, multiple small projections are formed on the surface of the parts to be welded. In this process, a PW and the pieces are placed between two electrodes, usually copper alloys, and the electrodes apply a force, pushing the collapsing projection into the other piece, which closes the gap between the two pieces and creates a weld nugget. This is really similar to spot welding, but in this case, the electrode does not produce heat.
The equipment used in this process are mainly for the second nut bolt feeders, nut verification system, pins and electrodes, and projection welders. All of this equipment is made of different materials so the process can happen.
This welding process is commonly used to weld parts of different sizes, such as blanks to sheet metal, or parts with different material properties, such as copper or steel. Projections used in PRW fall into 4 basic categories: stamped, which includes thin materials, sheet metal or foil; machine, usually used in thicker metal; coined, also in thicker metal; and corner, an edge of one of the part is made against the edge of the other part.
The advantages that has this process is geometrical stability, used mainly for PM power metallurgy parts, increased output due to simultaneous welds, extended electrode life, wide range of components, and minimum surface marking at one side.
Well, some of the limitations are the poor surface finish due to surface films of the piece and cleanliness, complicated process, is not useful in all pieces due to its composition. It cannot be made in really thin work pieces, and it can be really expensive.
The applications, where projection welding is most commonly used when special nuts, small fasteners, special bolts, studs, and similar parts are used as projections on the portion of the part to be welded. Projection welding is also used for welding parts of refrigerators, condensers, oh my god, these words are so complicated. Refrigerator, racks, grills, etc. Apart from that, projection welding is used in automobile workshops, ship welding works, and sheet metal working.
Well, these are some of the final products, and we're gonna see a little bit of our video.
Now we're going to talk about butt welding, which is a different process. The description of this different joining process is it is a circumferential butt welded joint, and the most common type of this is employed in the fabrication of welded pipe systems. It is the most universally used method of joining pipe to itself, fittings, flanges, valves, and other equipment. And this welding technique is widely applied in situations where a quality weld is desired. This process consists on two bars that are connected to a power source so they can be used as electrodes. Then the ends are pressed together and contact resistance is generated in the contact point. And this causes the melting of the material. And finally, the power is cut and the ends are fused. The joint part is cooled and the processing is finished.
Some of the equipment that is used in this kind of process is mainly the carbon butt welding machine, industrial heavy-duty offset butt welder, and extrusion welders.
Some of the materials that can be joined in this process, something that is an advantage in this process is that it can be applied to a wide range of materials, including carbon and stainless steels, nickel alloys, aluminum alloys, and copper alloys. And these can also be used to weld titanium, but you need to use an inert gas to prevent embrittlement.
As you can see, this process has more advantages than limitations. First, we're going to talk about the advantages. The first one is multiple butt welds can be created over the complete joint area in a variety of section sizes and shapes. The second, the weld can be performed for a large variety of materials such as steels, aluminum, stainless steel, nickel alloys, and titanium. The weld creates a solid face joint. The welding process can be completed automatic or semi-automatic without hitting the arc at a different angle. The butt welded joint is powerful and permanently sealed. Butt welds generally have a smooth surface as the filler is deposited into the groove. Butt welded pipe fittings are low cost. And last one, the butt welded joints occupy less space in a structure. And in the limitations, we can see only changes of porosity in some butt welds, and the edge preparation is required while working with a thick metal piece.
As we said before, some of the applications include pipes, bulbs, flanges, and fittings, but they are commonly used for pipe joints, which are not changed and assembled, for example, in the underground piping systems, long-distance pipelines, and among others. And this process finds application in most major industry sectors. For example, in the road transport industry, wheel rims are made from flash welded rings. Another example is in the aerospace industry, where it is used to weld undercarriage struts and engine rigs. And for the oil sector, drill pipes are made with flash welded fittings attached. And in the rail transport, the process can be used to join rails and crossovers.
Here in the final products, we can see, as my classmate mentioned before, the pipes, some wheel rims, and the struts that go in the wheels of the planes.
And that's all. Thank you for watching.